Hello and welcome. Today we will do our second quiz and we have left off in exercises quiz 2. And I'm already in. So let's see. This is a quiz for the following sections: string, vectors, move semantics, modules, and enums. Let's build a little machine in form of a function. As input, we are going to give a list of strings and commands. These commands determine what action is going to be applied to this string. It can either be uppercase the string, trim the string, append bar to the string a specified amount of times. The exact form of this will be the input is going to be a vector of a two-length tuple. The first element is the string, the second one is the command. The output element is going to be a vector of strings. So let's see. We have here a public enum command, and these are basically the commands: uppercase, trim, and append usize. Usize is basically an unsigned integer. Here we have a module, my module. It firstly imports the command enum using super command. And here we have the first to do, complete the function signature. So here we have a public function transformer. It takes an argument input. We have here to define the type and also the return type. Complete the output declaration. So also here we have a variable which is mutable output. We have to define the type. And as you can see, we are then iterating over the input through an iterator. And it's already put into a tuple. So on each iteration we have these two values. And all it does in the end is it will return the output. All right. And this is called dereferencing. I forgot the name. Now it came to my mind. It dereferences the structures the iterator over here. And then we have our tests. So we have another to do over here. What do we have to import to have transformer, this function, in scope? So that's what we have to do here. As you can see, the command enum is already imported, and then we have a function here. It works. Basically, this calls the function transformer we have to implement over here, and it passes it a vector, and each element of the vector holds a tuple which has two elements inside it. One is a string and the second one is a command. And as you can see, all of these have the type string. String, not string slice. Just to remember, that's why we have here into, because this string slice will be put into a string. So, as you can see, we have 4 elements in this vector, and each element, each tuple, holds 2 elements. And here we have the assertions. So, for example, output 0 in the output will be hello. So we have to make this all uppercase. The second one basically removes the white space with command trim. The third and fourth one will append bar to the given string. So here we have foo and it appends bar one time. So we have foo bar. Second one, we have bar and it appends bar 5 times. So bar, and then 5 times we append bar. Okay. I think the first thing I will do is just import this transformer function. So we basically just have to import this module and then the transformer function. So I will do it with super my module and transformer like that. I'm doing this for consistency because here the super is also called. We could also basically just left this out like that. It will also work, but for consistency, let's use super. So this will just import my module and transformer, as you can see. All right, and now we can basically implement the function. So as input, we will get, as you can see here, a vector which holds tuples of 2 values, string and command. So what we can do here is excuse me, we can type here vec. This will be the input, and then it will get a tuple, and in this tuple it's a string and a command like that. It holds the tuple, it holds a string and a command like that. All right, and the return value is basically a vector which holds strings like that. All right, complete the output declaration. So also over here it's basically the same. So we have vector and string, because you can see we are returning a vector of strings. So in the first element in the vector will hold hello, the second one will hold this, the third one this, and so on. Excuse me. So here it's creating a new empty vector, but actually if we do it like that, I like it more, the syntax, but you can leave it as you wish. It's basically the same. And we are here iterating over the input vector and destructure it. The right word is destructuring. So we are destructure this tuple. So the string will be in the variable string and the command will be in the variable command. And iter over here will return, I have opened that here, iter will return an immutable reference, as you can see. So we have to keep that in mind. So the first thing we basically do is we look what is actually needed to do or what is required. So I will put the match statement here for the command. And then, as you can see, we have here different commands, uppercase, trim, and append. So let's see. If we have, for example, if it gets past uppercase, we will do something. If it's trim or append, we will do something else. So command and uppercase, and if it's like that, we will take the string and we will call onto it the function to uppercase, and this should do. Then the second one, command trim, and if we have this command, we will trim this string, trim, and I will show you that really quick. So rust trim, let's see, where is it? Trim. So trim will actually be called on a string slice, and it will return a string slice. Returns a string slice with leading and trailing white space removed. So basically you can call it on a real string, but it has to be a reference, or on a string slice like over here, and all it does, it will just remove white space. All right. So that means we actually, as this will return a string slice, we have to put it into a string, because as you remember, we will return a vector which holds strings and not string slices. So just you remember that. And the third one will be append, right, append bar to the string a specified amount of times. All right, and this will hold usize. So this will be count, let's say, and we just basically there are two ways. We have string, and we can append bar and repeat count times like that, like that. And we have to dereference count over here, because as I've said, we are returning here references. So count in this case will be a reference like this. This is implicit, but we have basically to dereference that one. And then we have to basically push this stuff we are doing here in the vector. So what we need to do is we put this one in a variable, let's say string or s. This will be of type string, and then we can basically just take this output and call push, and we will push the modified string, and this will happening in each iteration. So we iterate, we will apply a command and modify the string, and then the modified string will get pushed to the vector, and when we have iterated over all the elements in the input vector, we will just return it. So let's see if this is actually compiling. I hope so. And it's not compiling. Let's see. Help add semicolon here. All right, and over here cannot be used to concatenate two string slices. So this is basically a reference to string, and we have to make that owned. So the first thing I forgot is to add here a semicolon, because this is an statement and not an expression. So we have here let equal match command, and we have to add this here. The second thing is we have to make this, because this string over here is a reference, as I've said. Iter will return references, immutable references. So we can do that here, to owned, let's say, and let's see. All right, and it's compiling. Now, as I've said here, there is another method, and I like that a little bit more, because as you can see here, maybe I should explain that one. We have here the plus sign, which means appending to a string, and we have to pass it a reference of a string slice. And that's what I found in the book. So over here, I hope you can read it. Let's zoom in a little bit. Over here, we can see we have here string hello and string 2 world, and then we are appending. So basically the first one is an owned value, and the second one has to be a reference, an immutable reference. And this is because this plus sign is implicitly standing for this add function, which first takes self. So self will be the owner, that's S1, and then it appends the other stuff with references like that. So that's basically that one. And because we have here, as you can see, we have here a reference, we have to basically, or let me see if it's working like that, because in fact we have, no, as you can see, we have to do it like that. We have to pass a reference like that. All right, and there is another method. So let me show you this one. So there is a macro format, which is actually like the print line, but format will return a string or a formatted string. So we can take string, that's this variable, and then we can append to it this or repeat count. And count, I guess, has to be dereferenced like that. And as you can see, we have the same result. So over here in the format macro, this will be dereferenced implicitly, and then we just do it like that. You can use either one. I will stick to the first one, but as you can see, both are possible. So we are basically done, but I will show you something. So actually this iter, as I've said, will return this will return immutable references. And now there is another one which is called into iter, and what this does, it's basically returning owned values. So over here you can see iter iterates over references, and iter mute, which iterates over mutable references, and into iter, which iterates over t, so an owned value. And for example, if we have a for loop over here, what this basically does, it will implicitly call into iter. This trait has one method, into iter, which converts the thing implementing into iterator into an iterator. Let's take a look at that for loop again and what the compiler converts it into. So we have actually into iter, which will be applied in a for loop if you don't put anything else. So this is not necessary because it's implicitly done. So let me see. Like that. And then basically we have here, these are owned. These are not references, these are owned. And what that means is we actually don't need this over here. Don't have to dereference it. And also, I guess that's it. Let me see. And as you can see, it's also passing. Yeah, I think we don't even need this one. Let's see. As you can see, it's compiling. So to owned, basically, this string before was actually a reference like that. But because we have now here implicitly into iter, it will move these values from vector into this one as owned. So this is an owned type, and we don't have to make it owned 2 times. So as I've said, we can remove that one. We have already dereferenced it, and we can remove that one. So like that. Let's see. Like that. And as you can see, this looks a lot more clean than the other one. I don't know why they made it iter, but maybe just to make you confused, or because we have covered the move semantics, so you have to do it like that to learn about owned types or references. But as you can see, we have made it a lot more clean like that, and the input and basically the output will get returned anyways. So we are here modifying the values directly from here. All right, and I guess that's it. We have done another quiz. And let's see the next topic, which will be options. See you then.